In this video, we're going to be looking at graphing exponential functions using an initial value and a base. So for this first example, we see we have an initial value of 2 and a base of 3. So the first thing we want to focus on is the initial value. This tells us the y value when x is 0, which on a graph is our y-intercept. So I'm going to take one of these points that is currently at the origin, 0, 0, and I'm going to put it at 2 on the y-axis. And this is my initial value. So I plot the initial value on the y-axis, and then I'm going to use the fact that the base of this exponential function is 3. So what that means is that from the initial value, when I increase the x value by 1, I have to multiply the y value by 3. So 2 times 3 is 6. So again, when I go over by 1 on the x-axis, I take the y value and I multiply it by 3, which means if I was going to plot the next point out, I would go over 1 and then multiply 6 times 3, so that would be at 18. But for our purposes here, these 2 points will give us enough to sketch the rest of the graph or to be able to identify it if we see it later. So when we sketch this graph, remember it's going to have that boomerang shape. This has a positive initial value and base, so we kind of expect this to hug 0 and then come up through the initial value and through the other point, something that looks like this. And so here we have our initial value, our y-intercept, and we've used our base, multiply the initial value by the base, and that is our y value when x is equal to 1. Now let's try this again with a different initial value and a different base. So my initial value is -4. Remember, this is our y-intercept, our y value when x is 0. So I'm going to take one of my points, and I'm going to plot it at 0, -4. Now I want a point that has an x value of 1, so I would take the initial value and multiply by the base, which is 2. So -4 times 2 is -8. And so I'm always increasing that x value by 1. And so now I can see these 2 points. If I needed my next point, I would take -8 and multiply again by 2. And so if I went over one more, this would be at 16, which is off the screen. You can see these numbers get very large very fast. I want to draw this again with the tail end of this hugging 0 on the y-axis, that is skirting across the x-axis there. And so when I draw that, it's going to look something like this. And so this is going to be a nice example of what happens when our initial value is negative and our base is positive. That number is going to get larger as a negative number, and so the graph will turn downwards, as we see here. Now let's look at an example where we have a fraction as a base. And I know there is a tendency to get really, really upset about having a fraction anywhere near your person, but relax, we've got this. So let's just take it a piece at a time, just like we have done before. So the first thing we want to do is to plot the initial value. So the initial value here is 12, pretty tall. So we'll go up there and we'll plot that point. And now we have a base of 1/3. So all we need to do is exactly what we did before. When we wanted to find the y value associated with x equals 1, we took our initial value and multiplied it by the base. So here we're just going to take our initial value and multiply by 1/3. And so when we do that, 12 times 1/3 is going to be 4. Another way of thinking of that is if you have a fraction that is 1 over some number, and again this has to be a fraction with 1 over some number, that is the same as dividing by the denominator, that is the bottom part of that fraction. So this is essentially 12 divided by 3, which of course is 4. There is zero wrong with putting that into a calculator. In fact, if you struggle with that sort of math, I encourage you to put that into a calculator. And so now what we see is we have these 2 points, but the question is, how do we draw the rest of this exponential function? So if we think about it, the next point out, if we were to go to another point where x is equal to 2, I would have to take 4 times 1/3, and so that would be 4/3 or somewhere around here. And if I continue multiplying, what I'm going to see is that number gets really, really close to 0. And so when I sketch this function, we will see that it starts off pretty high, and because we have that base that is a fraction that is less than 1, we're going to see the number get smaller and smaller and smaller and get closer and closer to 0. And even though that looks like it's at 0, it's never actually getting there. For our final example, we'll look at an exponential function that has a negative initial value and a fraction less than 1 for a base. So, just as before, let's plot our initial value. Our initial value is -8. So that's going to go right here. Now I want to find the next point over, so I'm going to take that -8 and multiply by 1/2, which is the same as dividing by 2. So -8 times 1/2 would give me -4. And so now I have these 2 points, but I kind of wonder what the rest of the function is going to do. So if I looked for what the next point would be, I would have to take -4 and multiply by 1/2. Well, -4 times 1/2 is -2. And then I could do that again to find the next one. -2 times 1/2 is -1. And then we would have -1/2 and -1/4. And so this thing is going to be approaching 0, but never actually getting there. So when I sketch it in, it will look something like that.